So hello all. I would like to introduce you to my team, Team SanSkript. We are team number 25. I would request my team members to introduce themselves. Starting with me. Hello all. I am Rushabh Gajab.
Hello, my name is Viresh Bhurke.
Hello, I'm Milind Deshpande.
Hello, I am Siddharth Sharma. Now I will take from here to explain the basic flow of execution and our language design. So in our basic execution flow, we have input.skt files in which we have written our program, and we have created our analyzer.py file in which the .skt files are passed through which the code gets tokenized and an intermediate syntax is generated. This intermediate syntax is further passed into our evaluator, which is written using the prologue. And finally, a subprocess module is called within our runscript.py file, which is our main file, and we get the final output. Moving forward, we have the following data types supported in SanSkript. First is the int, then next Boolean and string. Apart from that, we have also implemented the float data type, which is an addition to the design requirements as defined in the project deliverable document. Moving forward, we have the following conditional statements. The first is the if then, the second is the if then else. Now, explaining the basic snippet of our programming language, we have incorporated the following Sanskrit syntaxes. The start and end blocks begin with the word keyword, arambh and ant respectively, and the word print is replaced by the word likhyam, and whatever is written, whatever within likhyam gets printed on the screen. Moving forward, we have the following three loops. The first is the while loop, the second is the traditional for, and the third is the for I in range loop. So, as you can see in the example, all the loops begin with the starting opening bracket and ends with the closing bracket. And all the statement declarations end with the double pipe operator. Moving forward, uh, you can see the examples for the traditional for and the traditional for I in range loop respectively. And further, we have the following operators supported in Sanskrit. The first is the arithmetic operators. These are the addition, subtraction, multiplication, division. And we have the logical and, logical or, and logical not operators. Apart from that, we have also implemented 6 comparison operators. These are again in addition to the basic language design requirements, which were defined in our deliverable document. These are the greater than equal to, less than equal to, double equals to, and not equals to. Now, coming forward, the tools used in the project are Python 3, in which we have written a runscript.py file and our tokenized function. And we have used Prolog, in which we have written our parser code. Now, from this, I would like Rushabh to take here and explain the grammar of our code.
So as for the grammar of the Sanskrit language, we have used the DCG notation for defining the grammar. Uh, So as for the entire grammar, each of the blocks of the programming language have a specific name, and that is the convention that we have followed throughout the design of the grammar. So as we can see over here, the header predicate is program, which incorporates a block. Block incorporates the keyword rm, declaration block, statements block, and the ending keyword un. Uh, Now coming specifically to the declaration block, within the declaration block, we have incorporated variable declarations, string declarations, single declarations, or declarations followed by several blocks of declarations. As for the statement block, we have statements, single statements, uh, single statements followed by a block of several other statement blocks, conditional blocks, and loops. Uh, and in a similar fashion, the conditional blocks and loops can also be followed by several other statement blocks. Now, coming specifically for the loops, as already mentioned before, we have incorporated traditional while loop, traditional for loop, and for in range loop. Moving forward, we can see that uh, as for the conditional block, we have specifically designed the standard if then block and the if then else block. Another conditional block that has been added to the grammar as a part of the design is the ternary operator. We can see the syntax of each of the conditional blocks as we can see it on the screen. For the if then and if then else block, it is the standard syntax that is followed in programming languages, and the similar suit is followed for the ternary operator, as can also be seen on the screen. Next, we have incorporated several operators, some of them being the incremental operator, that is the plus plus and minus minus, and relational operators. As already mentioned before, the relational operators are certain of the additional functionalities that we have added in our grammar. We have also incorporated the print statement, as well as uh, uh, several Boolean operators. Moving to the next slide, we would be able to see that we have incorporated expressions that deal with addition, subtraction, multiplication, and division, and the precedence has also been incorporated in this. We have also uh, incorporated identifiers and identifiers followed by expressions. Another thing that we have incorporated within our grammar is values, that is numbers, and different data types, as well as assignments. Can you move to the next slide? So from here, tokenization will be taken up with by Milind.
Thank you, Rushabh. So I'll be explaining the tokenization part. So this is the first step in while processing any SanSkript program. So whenever a program is written in our programming language, it is initially broken down into individual tokens, and this tokenization process is done using the lexical analyzer, which we have written in Python. And this tokenized output, which is generated by the lexical analyzer, will be further passed to the parser. So as you can see on the left hand side, there's a sample input program, and after it goes through the lexical analyzer, the output tokens on the right hand side will be generated, as can be seen. And then after the input tokens are generated, they are basically passed like an intermediate syntax or an output intermediate form is generated, as can be seen on the right hand side. So this is basically the intermediate syntax, which is further passed to the parser for further processing. And this parser is implemented in Prolog, and DCG is used for checking the grammar. So this is the tokenized function. Like this is the token specifications list, which we have defined. So all the possible tokens which can come in our program are all specified in this token specification list. And this is the tokenized function, which basically tokenizes the SanSkript program, as I said before, and writes it to the tokens output.txt file. And also it returns an intermediate syntax in the form of a list, which is the tokenized output list. Now the evaluator will be explained by Viresh.
Hello. In this section, we will be talking about the evaluator. So for this project, we have three main distinct type of evaluation structures which are followed. So the first one is an evaluator which takes the environment and substitutes the values and gives a single numerical output, which is done by the done for the evaluation of an expression. The second type of evaluation is it evaluates statements further within the evaluator in conditional blocks or loops, such that it takes the values from the environment and gives a new environment for it. Moving on. So over here, I was talking about the evaluators which update the environment. So as we can see, the string declaration updates the environment with a string value assigned to a variable. So in declaration, we have the variable and string declarations, which can be further called into multiple declarations. So in statements, we have the loops, conditional blocks, and multiple statements supported along with print statements. So next. So over here for evaluation of Booleans, so Boolean operators, Boolean evaluator will evaluate a Boolean grammar as well as a conditional grammar. and give us a result in true or false. So in the loops, we can see that the loops are executed by following a specific structure, which is they first take the incremental operation variable, and then they evaluate the statement, and then in that statement the environment is updated, as well as the loop is further called recursively, and is evaluated till termination. So next, so over here we can see that the loops operation takes multiple types of loops, which is the while loop, the range loop, and multiple loops as well. There are conditional blocks which support if then else and if then operators as well. So next. So here I would like to talk about the lookup and update as well as the print evaluator. So the print evaluator only takes the environment and the tree structure of printing a statement. In evaluation of print statements, the output is written in the console. Finally, we have the program and the block outputs, block evaluators, which evaluate the declarations and statements, and the program block evaluates the complete block it's by itself. So all of these tree structures are called within their trees, and they follow a specific tree format due to which they can be nested, and they can be called in nests as well. So next. So the evaluator uses pattern matching, and this is implemented in the DCG and Prolog. So the lookup and lookup and update are the key features which update our environment. Next.
Oh yeah, thank you, Viresh. So I'll be explaining the program execution from here. So first of all, this is so first of all, this is the repository, to our like this is the project repository. So first of all, you should download the zip folder, or you can also clone it to your local machine, and then this will be installed. This this is the root directory basically. So if you navigate to the root directory, and if you open the command line here, project, this is the starting point of our project. Are written in SanSkript should be written in the data directory. So as you can see, and the extension is .skt. So I'll show you I'll run the calc.skt program. So the command for this is python run script.py and the program name. Oh, I'm sorry. There's a typo in this. Yep. So as you can see, this is the output of our program. And also when you run the program, .sktc, which is the intermediate syntax file, is also generated in this directory temp. And also the tokens output with the tokens separated on the new line are also generated. So these are the tokens which will be generated. Okay, so that's it. That's the execution of our program.
Also, the commands can be executed from the command line itself as well.
Oh yeah, they can be executed from the command line shell as well. So okay, so this is we can also invoke the command from the command line. Okay, so these are the terminal commands. These are intermediate files which I just shown. This is the intermediate syntax file which I had just shown in the demonstration. And in the future scope, we can also support read user input, input provided by the user, like a variable, like a integer or something. Then we can also give support for writing the comments. Then we can include more data types like long, double, etc. And we can also support more string operations like append, finding a specific character, and reversing a string. And also we can give support for writing functions in SanSkript, and also for defining data structures. So that's it. That's pretty much our project. Thank you very much.